Welcome back to Concept 47. We're going to continue with some practice problems looking at the normal curve. Look at these practice problems. Now, just a reminder, the abbreviation for mean is that is the Greek letter mu, and standard deviation is that Greek letter sigma. So a value x is randomly selected from a distribution of survey responses about the grit. That was in our last example. Which follows the pattern of the general normal curve, which I have pictured over here to your left. So look at number 1. Now this notation is asking you to find probability. That's what capital P is. And then inside the parentheses, that refers to our normal curve. So what this is asking you to find is the probability that some score x is less than or equal to the mean and 2 standard deviations below. So look with me on the normal curve at mean and then 2 standard deviations below. So what is the probability? Well, 34% of the data values are 1 step down and 13.5 are between 1 and 2. So we can add those percentages, and that will give us the probability that a randomly chosen score will fall between the mean and 2 standard deviations below. So let's try another one. Number 2 asks us the probability that some score x will be less than the mean. So if we look at our normal curve, here is the mean, and then some score that's less is everything to the left. Now we can add up those probabilities, but in earlier notes of this concept, it was mentioned that 50% of the data values will fall below the mean and 50% above. Number 3, we want to find the probability that some score is between 2 standard deviations above the mean, so see how that's mu plus 2 sigma, and the actual mean. So if you look on our chart, we're going from the mean up to 2 standard deviations above. So we're going to add those percents of 34 and 13.5, which we've done earlier, so we can just remember that that is 47.5. And then finally, we're finding the probability that some score is less than 3 standard deviations below. So I'm going to go 3 standard deviations below, which is just here, and that is this percent. So that is a very small amount of our data set, 1/1500. Let's answer another question. This says, describe these results in reference to standard deviation. If a school district other than Liberty was chosen at random, what is the probability that their average was above Liberty's average? Notice that it's stated that for Liberty, 51% responded favorably. So if we refer back to that grit curve, we remember that 60 was our mean and then 9 was our standard deviation. So if we step down 9, we're at 51. So 1 standard deviation below the mean is where Liberty's average is. So if we want to know what percent of the other districts responded was above, then it would be all of the area to the right of that standard deviation mark. So if we add all of those up, we get 34 and 34, which is 68, 13.5, 2 and 3500ths, 1500ths, and that would be 84%. So 84% other school districts than Liberty would be scoring above that average. Now, if a school district other than Liberty was chosen at random, what's the probability that their average would be below? So looking back up at the chart, that would be to the left of where Liberty is scoring. So that would be the other side of 84% out of 100 which is 16, but we can also add up the percentages. Whoops, I just need 13.5. Add up the percentages in those standard deviation areas. So 16%. So that's just an example of how you can use normal curve and in reference to real-life survey data to answer questions about what was happening in that survey. Now I want you to practice creating your own normal curve based on a situation. So once again, we're talking about this panorama survey that was given to the U.S. students and Liberty Public School students. And this time the question was about self-efficacy. So how much students believe that they can succeed academically. So it is normally distributed with a mean of 55 and a standard deviation of 10. The range is 1 to 100% like normal. So first let's label the normal curve. So right in the middle, draw a line, and then 3 lines above and 3 lines below. On that middle line, now that's our mean, so we're going to put our label just below of 55. Then we'll add 10 for each line above. And so 1 standard deviation above will be 65, 2 will be 75, and 3 will be 85. And then let's go in the negative direction and let's subtract 10. So the scores below will be 45, 35, and 25. All right, and now let's include ranges for the 68, the 68, 95, and 97 rule. So we can just draw that in. So 68% will be these two. And then our 95 will be here. And then our 99 will be 0.7. There. All right, now question A says, what percent of the schools taking the survey between 45 and 65, taking the survey responded between 45 and 65? So let's clear this off. So that would be 45 and 65 right up the middle. So 1 standard deviation above and below is 34 and 34% of the data. And so together 68% of the schools would respond between 45 and 65. And then B says, what percent of the schools taking the survey had a favorable response of more than 65%? So that would be to the right. And so that would be 13.5% of the data, 2 and 3500ths, and 1500ths. So if we add all that up together, that is 16%. And then finally, the Panorama Survey Company recommends schools take action to help students improve their self-efficacy if students respond at a rate of 35% or less. So about what percent of the schools administering the test need to have an action plan? So that would be everything to the left of that score. And so the percentages of data that are to the left are 2 and 3500ths and 1500ths, which together is just 2.5% of the schools would need to have an action plan. All right, this concludes the part 2 of the Concept 47 notes on normal distributions. So now you will complete the teacher talk with your teacher and then the Math Excel practice and take a quiz.